These are the frequently asked questions for Algebra 2 for section 4-6, day 2. I'm going to start in here with number 29. And some of these, I don't know whether or not you'll need them or not, but you know what? I just love doing these, so I'm probably going to do a bunch of them. So number 29 has x squared minus x plus something. Well, that something is our c value. And to get that, remember, we're just going to use that little formula b over 2 squared. And we have to think of this as standard form. So our b over 2 squared comes from looking at this as ax squared plus bx plus c. So my b value right here is a negative 1. So this will be negative 1 over 2 squared. Well, you just square the numerator and you square the denominator, and we're going to get 1/4. Or you can think of it as negative 1/2 times negative 1/2. And then when you multiply fractions, you do top times top and bottom times bottom. Either way, we're going to get a c value of 1/4. And that's what we need right there. So b over 2 squared will get us that piece every time. All right, now the next one here is 35 that I'm going to solve by completing the square. And we have, oh, I better leave some room for the other two I have here. So first thing I do is look at that and say, okay, is that a perfect square trinomial? Pretty obviously it's not. So I'm going to go ahead and move that 7 over to the other side by subtracting 7 from both sides. So now what I need to do is come up with the value that will make this a perfect square trinomial. And it's back to b over 2 squared to figure that out. In this case, we have negative 12 for b. And negative 12 divided by 2 is negative 6, and negative 6 squared is 36. But what you add to one side, you have to add to the other. Now, this is a perfect square trinomial with an x in the front, so first times first would give me x squared, and a negative 6 in the back, so that it would multiply to positive 36, but add to a negative 12 in the middle. And over here, we have the not so pleasant 29. Now, why is it not so pleasant? Because the next step that we do is we take the square root of both sides, and the square root of 29, we put that plus or minus on there because whenever we write the square root, we have to introduce the positive and the negative. But there's nothing we can do with it. There isn't anything, any of those perfect squares that we can use to simplify that radical. So we just keep going and we add 6 to both sides, and we get 6 plus or minus the square root of 29. And again, at first, you think that's kind of a nasty answer, but you know what? We couldn't have gotten that answer by factoring. We never would have seen that by factoring. So that's a fantastic answer. It's an exact answer. And nothing is more enjoyable in math than getting yourself an exact answer. So 43 is the next one. We have 4x squared plus 10x minus 3 equals 0. So the 4x squared, definitely a perfect square, but that minus 3 in the back is not going to help me out. So I add 3 to both sides. Then, I absolutely remember what Mrs. Cedarholm said in class, that a has to be 1. There's a, and it is not 1. So that's the one kind of glitch about completing the square, is that we have to have a 1x squared. So what I'm going to have to do is divide both sides of this by 4. And that will give me x squared plus, well, 10/4 is going to reduce to 5/2 x equals 3/4. And now you can see the b over 2 squared is going to get a little more complicated here, but we definitely can still find that number that will make this a perfect square trinomial. So I'm going to have 5 over 2 divided by 2 squared. And of course, we don't multiply fractions, or sorry, we don't divide fractions, we multiply by the reciprocal. So what we're really doing is taking top times top, bottom times bottom, which would give you 5/4 squared, which is 25/16. Again, not the most pleasant thing in the world to work with, but it works, and that's what we want this to do. We want it to work. So that means x times x would give me that x squared in the front. And then notice, I already know what I have to put in the back, because that b over 2 piece is what I always need to put in this second position. Because remember, when I square it, I have to get 25/16, and this is exactly what I did square to get 25/16. So that's going to be plus 5/4. Now over here, you're going to have to do a little common denominator action and multiply this fraction by 4 on the top and the bottom, so that I can add those together. So I have 37/16 over there. And again, you know, part of that is not going to be fun in this next step, but the other part will work out really nice. So take the square root, x plus 5/4 equals plus or minus. The square root of 37, nothing pleasant about that, but that's okay. You know, we're not going to simplify it. There's nothing else we can do with it. But what's more important is we do not have a radical in our denominator, because the square root of 16 is 4. So you have to think of this as being separated here to make sure that you can find that. Then the next piece would be to subtract 5/4 from both sides. And you can certainly leave the answer like that, or because they both have 4 as a common denominator, you could go ahead and just write it as one big fraction over 4 as well. It doesn't make any difference. Each one of those answers is correct. However, when we're completing the square, we tend to leave those as 2 separate fractions. The second answer that I have here looks more like somebody was using the quadratic formula to do this problem. So we tend to leave those as the 2 fractions. Then I had another one up here that I wanted to go through, and that is number 45. And we have 25x squared plus 30x equals 12. All right, now normally we move the 12 over and say, oh, let's see if that's a perfect square. Pretty obvious the 12 is not a perfect square. So what I need to think of is the next step. The next step is I don't have a 1 out there in front for my a value. So I'm going to have to divide both sides of this equation by 25. And when I do that, I will get x squared plus, and then you reduce 30 over 25 by dividing 5 out of both of those. So that'll be 6/5 x equals 12/25. And as you're doing these, you realize that's okay that that's 12/25 over there. You know, the 25 is going to be a perfect square, so this is not going to be a bad thing at all. But I still need to come up with that c value. So I do b over 2, and I square it. I'm going to get some room here so I can show you all the fraction stuff we have to do here. So we have 6/5. We have to divide that by 2, and then we have to square it. And again, with fractions, you don't divide, you multiply by the reciprocal. And this one, you can actually do a little reducing if you want to, because 2 goes into 2 once and into 6 3 times. So we would get top times top is 3, bottom times bottom is 5, and when you square that, you're going to get 9/25. So it's this 9/25 that we need in those positions, because whatever you do to one side, you do to the other. That allows me to write that as a perfect square trinomial. Obviously, I'm going to have that x in front, and then I think, well, what did I square to get 9/25? That was 3/5. And over on this side, 12 plus 9 is 21. And then we keep going. So we're going to go ahead and take the square root of both sides. And again, you're physically writing down that square root symbol. That means you have to do the plus or minus. So square root of 21 over the square root of 25 is 5. And then we're going to subtract the 3/5 from both sides. So negative 3/5 plus or minus the square root of 21 over 5. And there it is. Again, you know, solutions that we could not otherwise have found perfectly without the completing the square process. Those answers are elegant in math. Getting a perfect answer, getting it as simple as possible, that's an elegant answer. Then, in number 50, we want to go ahead and change a standard form equation into vertex form without using the cheater's method that we did earlier in this chapter. Because what we did before was we cheated and used x equals negative b over 2a to figure out what the vertex was, the x and the y coordinate, and then put it back. We're not going to do that anymore. We're better than that now. We know more than that now. So here's what I know. Negative 1 is not a perfect square because you cannot multiply a number by itself, times itself, and get a negative. That doesn't happen. So I'm going to have to move that 1 over. And as you write it down, hopefully you realize, oh, wait a minute, the 2 has to go as well. I have to get rid of that 2 in front of the squared term. And this usually makes people squirm a little bit. You know, there's a lot going on here, but it's all going to work out, so just hang in there. And over on the right-hand side, we would have x squared minus 3x. Now comes that all-important part of figuring out that b over 2 squared piece that we need. So right now we have a negative 3, and we're going to have to divide that by 2 and square it. And negative 3 halves times negative 3 halves would be a positive 9/4. All right, so now it's gotten interesting over on the left-hand side because I can't add those together unless I have a common denominator. I'm going to need to multiply my numerator and my denominator by 2 in order to make that happen. So that will be 2y plus 2 when I distribute that 2 over 4 plus 9 over 4. And let me move this. And on the other side, I have my perfect square trinomial. X times x will give me x squared. And then my little negative 3 halves here is what I squared to get 9/4. Looks like so. Now, here's the thing. I've got a common denominator over on the left, so I'm going to go ahead and combine those. And now what I have to do is carefully move everything back over to the other side so that y is by itself. So I take a look at y, and I realize, all right, that 4 down there is causing trouble. So the first thing I have to do is multiply both sides by 4. And that will give me 2y plus 11, because the 4's over here are going to cancel right out, equals 4 times x minus 3 halves squared. All right, next thing to go, the 11. Got to get that out of there. So I'm going to have to subtract 11 from both sides. So 2y equals 4 times x minus 3 halves squared minus 11. Lastly, I have to divide everything by 2. So over here, the 4 and the 2, we'll do a little reducing. But that 11 in the back is going to have to stay 11 halves because that did not work out perfect. But the great thing is, once again, we have ourselves something that started out in standard form, and we can now get this into vertex form without having to use the cheater's method. So hooray for us! Is it complicated? Yes. But boy, we're becoming master manipulators of numbers and letters there. That is some good stuff. All right, now back up to 51, which I just have to point this out. Look at all this wonderful math that we do. And totally able to follow along with that. You just move things over and you move them back. But that is just a beautiful problem. That is a beautiful problem. All right, let's look at 51. Okay, got some trouble here. First of all, there's a negative in front. I could go ahead and multiply everything by a -1 first, but you know what, I want to keep this in the same format that I did the last one, which would mean I'm going to go ahead and add 1 to both sides first. Then I have the problem where there's a negative in front of my x squared. It has to be a 1, and it has to be a positive 1. So everything here has to be divided by a -1. All right, now here's where the last one turned a little nasty on us, but this one is not going to be bad. And the reason I know that is just by looking at my b value. My b value is -4. So if I take -4 and divide it by 2, I get -2, and when I square it, I get 4. So what I do to one side, I have to do to the other, and this one works out pretty doggone sweet. So we have -y plus 3 equals, and now we have a perfect square trinomial, and this will be x minus 2, because remember, I had to square -2 to get that value. And now, I just want to move everything back so that I can see where everything is and what it looks like. So I'm going to go ahead and subtract 3 from both sides. So -y equals the quantity x minus 2 squared minus 3. And then I'm going to go ahead and divide both sides, or multiply both sides by -1. So this will be a negative x minus 2 squared plus 3. And again, very cool. You know, now we could see that our vertex there is going to be 2, 3, and that this one is going to open downward because of the negative that's out in front. So, you know, once we can get that in vertex form, everything's really sweet and easy to work with, and that's definitely what we want to do. All right, on the next page, number 53, is a think backwards kind of problem. It says find the value of k that would make that a perfect square trinomial, which basically means we want to focus on the fact that c is 25. So k would have to be divided by 2 and squared to give you 25. So there's two ways to do this problem. You can think backwards, and you could say, okay, I'm going to take the square root of that. That would get me 5. And what divided by 2 would give you 5? And that something is 10. You know, and just think through your steps backwards. Or go ahead and solve this like algebra, you know, and that would be k squared over 4 equals 25. Multiply both sides by 4, and then take the square root of both sides. But in this case, we don't need the negative because we see there are 2 pluses up there. Everything's supposed to be positive, so k would be 10. So I want you to be able to think forwards and backwards. And, oh, in this one, they were saying we could change the sign, so we should put the positive and negative piece in here. So go ahead and do that. All right, because they didn't specify. They are saying we can put a positive or a negative in there. Then, oh, I only had you do that one, huh? Didn't have you do any more? I kind of like those. Well, it's not like we don't have enough to take care of in this section already, so I'll go ahead and move on to the next type of problem here, which is number 67. So 67 has 3x squared minus 4x, and we have a 2 sitting over there. And the 2, yeah, pretty obviously, if we brought that over, is not a perfect square, but neither is the 3 in the front. So that 3 in the front has to go. I'm going to divide both sides by 3 and get x squared minus 4/3 x equals 2/3. I'm going to leave myself a little room there because I know I have to find that perfect value for c. So I'm going to need to take -4/3, divide it by 2, and square it. So that'll really be -4/3 times 1/2. Squared. And again, you can do a little reducing here. So we'll get a -2/3 squared, which is going to be 4/9. So I need to add 4/9 to both sides. that gives me a perfect square trinomial over here now, which is fantastic. And over on the right, going to have to do a little common denominator action. So 2/3 would need to be multiplied by 3 on the top and the bottom. That would give me 6/9, and I have to add 4/9 to that, so that will give me 10/9. And over here, again, you think about what did you square to get the 4/9? We had to square a negative 2/3. Then we would take the square root of both sides. So x minus 2/3 equals plus or minus the square root of 10 over 3. Square root of 10 is not simplifiable, but the square root of 9 is 3. And then we just add 2/3 to both sides. All right, so x equals 2/3 plus or minus the square root of 10 over 3. And again, you could write that all over one fraction, but then it kind of looks like an answer where you have used the quadratic formula, and we don't want to do that. We want to have something that looks like we knew what we were doing when we were completing the square. So we would leave 16 plus 22x equals 3x squared. And I'm going to go ahead and move the 22x and the 16 over to the other side. Because if we're going to solve this by factoring, we need to have a 0. So now that I have that, I see that there's no common monomial factor. I need to use a combination here, outside times outside, inside times inside, to find this one. And there's not a whole lot I can use in the front. It's 1 and 3 and 3 and 1. But in the back, I have a few I'm going to have to check out. And that's not all of them, but I kind of want to stop there and see whether or not I'm going to have enough at this point. So they had to multiply to negative 16 in the back. And then we have to do our outside times outside plus inside times inside to get negative 22. And I realize right there I have negative 24 plus 2, and that'll do it. So then we have first and first, last and last. Scoot that up a little bit. And then we need to find the zeros. So 3x plus 2 equals 0, and that'll give us an x equals negative 2/3, and x minus 8 equals 0 will give us a value of x equals 8 for that one. Oh, there's a slight interruption here, and it's Friday night at almost 9 p.m., and I think I've got this set for you.